At this point, we're ready to put our distillation apparatus into the hot sand bath. Now, as I showed you before, we've already turned on the sand bath and we've let it heat for a while. So it should be ready to heat the apparatus. I have the apparatus clamped here by the fractionating column because I'm going to have to lower this in all the way down close to the bottom. And because I'm using this large beaker, I won't be able to clamp here at the joint, which is where you would normally clamp. So as a result, I've put a Keck clip on there in order to hold it while it's suspended in, and it'll be held up by this. And I'll be lowering it in just a minute. Before I do that, I want to assemble other parts of the apparatus here. So we now have our fractionating column here. We come up to our distillation adapter. We're going to need to put a thermometer in. We come down to our condenser. We need to hook our condenser up to water. And then we need to put on our takeoff adapter. This is the takeoff adapter. It's going to fit on right here, like that. And we don't need to grease that because it's not going to be heated. So it's not really in any danger of freezing. So again, I'm going to take a Keck clip. I'm going to clip that on so that it's nice and secure. And then I may support this on this side just because it's a little bit heavy. So I'll be using clamps to do that. Finally then, often we would use another round bottom flask with a joint that would fit on the end, it would fit on the end of the takeoff adapter. But we're not going to be doing that for this experiment. Instead, we're just going to let the apparatus drip into this graduated cylinder. So we're going to clamp the graduated cylinder, opening open, but so that the liquid will drip in. That way we can monitor the volume that we've collected as the distillation proceeds. We also need to hook this up to cooling water. In order to do that, we're going to use rubber hoses like this. Now, we're going to use 2 rubber hoses. And I'm going to show you the direction that we hook them up because there is a specific direction that we need to hook these up. So we want to put water in at the lowest inlet in our apparatus. Because when we turn on the apparatus, there's going to be air inside the jacket. And we need to push that air out of the way. And as the water comes in, the air will naturally move to the top. So if we put the water in at the bottom, as the water fills, the air will move up, and come out the outlet. So I'm going to go ahead and hook up the outlet. And we just slide it on carefully. And it needs to go on to about a 1/2 inch depth or so. But if the tubes are the right size, they'll stay. So that's the water going back to the sink, and we just leave that dangling in the sink. And then what we're going to do is hook up water coming from the faucet. Like that. You can see it's getting heavy, so we're going to end up having to support this in just a moment. So to support it, I'm going to turn it like this so that you can see it. And I'm going to use this clamp, and I'll probably move this hose out of the way. And I may end up having to get another couple of clamps. So you can see, clamps are really useful. And we're going to clamp the graduated cylinder in, like so. And then, because this is separate, it's a separate stand, we can move it back and forth to get it to a relatively optimum position. And what I've actually done is I've set this thing, the tip of the takeoff adapter right onto the top of the graduated cylinder. Now I'm going to have to move that graduated cylinder down in a little bit. So I'm going to move that off for just a moment. because that's going to be our ultimate setup. And in the meantime, what I'm going to do is just, this is a good O-Chem trick here. I'm going to take my clamp and I'm going to lift it up so that it just supports it. I don't need to clamp it, I just need to lift it up. Okay, so we're now ready to put it into the heat, and for some reason my temperature changed. I must have bumped it. It's no problem. Let me turn it back up. We want it about 200 degrees, and it'll heat up. The reason why we want about 200 degrees is so that it's about double the temperature that the liquid should boil at. Okay, so at this point I'm going to lower it into the hot bath. So to do that, I'm going to have to move my support clamp so that I can move that side down. And on this side, I'm going to move my apparatus in. Now, we need, if you can see, I'm putting it in and shaking it. We need that to go down into these little pellets. So we shake it so that it'll sort of sink in. There we go. And now we can, I have to lower this a little bit here. All right, let me get my hand out of the way there so you can see it. There we go, it's in there. Now I'm going to tighten it. That one is stuck, but this one isn't. There we go, nice and tight. Another shake. We want it in good physical contact because that's how the heat is going to transfer. Now we're going to turn on our stirring. And if the stirring is working, I don't know if you can see it, we'll take a close-up later, but you'll see that there's a little vortex on the surface of the thing. Okay, so now we're in a position where we can place our graduated cylinder and clamp it in place. So I'm going to put it here, clamp it, and then I'm going to carefully lift it up. Lift up a little bit, there we go, so that it supports the rest of the apparatus. And finally then, I need to put my thermometer, that didn't work, okay. Trying to figure out how to support these. I probably have to put another clamp to support these things. So you can see it takes a lot of clamps to do O-Chem here. Let me see here. It's going to look a little funny, but we're not actually clamping it. We're just using the clamp to lift these tubes up so they don't kink. Just like that. That way the water can flow. Now, we're going to gently turn on the water. Got to be careful. Whoop. Can you see the water? So you see how the water comes in at the bottom, it pushes the air bubble out, and in fact we don't really need a lot of water flow. So let me give it a chance here. It probably will have a hard time even pushing that out. Let's see. I'll turn on a little higher. There we go. So that probably is even too much water. Oh, yes. Can you see it now? So that's probably too much water, but the other problem you have is that a lot of times the faucets, you'll turn them on to a very low pressure, and the washer inside will expand and shut it off again. So sometimes you have to turn it on a couple times. Finally then, we need to put in our thermometer. So the thermometer is going to go in from the top through the thermometer adapter, and we want the tip of the thermometer to be, maybe 1 centimeter below the side arm. Can you see it? So this would be about the right height. Now, our thermometer has a little septum around it to seal it, but the septum doesn't hold it very tightly. So therefore, I'm using a clamp up here to support that thermometer. And the only other thing I want to do is I want to make sure that with my clamp, because it's kind of holding it in place, that the thermometer isn't touching the walls. I need to move it back a little bit. There we go. Yeah, you know, so it. So you may notice that it's not perfectly square and vertical. You try to get it as close as you can, and it's not going to be perfect. And so I don't know if we can see the thermometer in the camera at the moment, but the thermometer is currently reading 23, 24. So it's getting warmth from the warm air that's coming up, but it won't start getting hot until the liquid boils and the vapor heats this entire apparatus up to this point. Now the problem is we're in a room. It's got air coming through it. As the vapor's trying to put heat energy in, heat energy is going to come out into the air. So we're going to insulate it. To insulate it, we're first going to put 2 pieces of foil over the top of the opening of our sand bath. Now what this does, it doesn't have to be sealed up perfectly. It just needs to kind of slow down the exchange of air in and out. And of course, by putting it that way, you can't see anything, so I'll turn it that way. We're just trying to slow down the exchange of air in and out. And that'll create a nice little oven so that when that gets hot, it won't cool down again. Then, what we're going to do is we're going to use this material. This material is called glass wool. It's a good idea to wear gloves when you work with glass wool because it's actually little fibers of glass, and the fibers will break and go into your skin and irritate your skin. Now what we want, this is kind of old and cruddy, but we can still use it. What we're going to be doing is wrapping around the fractionating column, creating sort of a puffy blanket. So when it's brand new and it's kind of in strands, you can do that a little easier, but this will work. And we need to go all the way up. Actually, once we get some on there, if you put a little outer coating of aluminum around it, it's not pretty, but it works, it'll keep it from falling off. Now, we don't want this outer foil to be too tight, and it would normally be maybe a little tighter here, but the clamp is underneath it. But the idea is we want to stop the air exchange so that the heat energy doesn't escape. And now we're just going to heat this thing, and it may take a little while. And we're going to start monitoring the boiling and monitoring the vapor and monitoring the temperature.